Welcome to 1337. Welcome to the future.
Welcome to 1337, the future of podcasts on the human element. I'm Max, your guide to understanding human behavior.
And I'm Sophia, here to explore the depths of the human psyche with you.
Today, we're diving into a world stranger than fiction.
Oh, yeah.
Quantum physics.
Yeah.
You might be thinking,
Quantum physics.
quantum physics, what's that got to do with me? But trust me, this isn't just some abstract science. It's the foundation of our reality, and it affects us in ways you wouldn't believe.
That's so true. I mean, quantum physics is behind so much of our technology, like from the smartphones we use to the GPS that guides us. And beyond that, it even delves into like the very essence of what's real, challenging our everyday perceptions.
I love it. So we've got 3 YouTube videos to guide us on this journey.
Okay, awesome.
We've got Novi's Decoding the Universe, Quantum Veritasiums, Something Strange Happens When You Trust Quantum Mechanics,
I love Veritasium.
and the entire history of quantum physics explained in one video from big scientific questions.
Okay, so we're going to be like unraveling the mysteries of this pretty mind-bending field, starting with its pretty fascinating beginnings. Who would have thought that something as simple as a light bulb could spark a revolution in scientific thought?
Right. It's so true.
Yeah.
The Novia documentary highlights how this like seemingly mundane object led to what's called the Ultraviolet Catastrophe.
Oh, the Ultraviolet Catastrophe.
Basically, classical physics just couldn't explain why a hot object like a light bulb filament doesn't emit an infinite amount of high-energy light.
Yeah, it was a real head-scratcher for physicists back then. Then Max Planck came along with a radical idea. He proposed that energy isn't continuous, but it comes in these, like, discrete packets, like tiny bundles, which he called quanta.
Okay, so instead of energy flowing like a smooth stream, it's more like a series of tiny droplets.
Yes!
That's a pretty wild concept.
Exactly. It's like saying you can't have half a coin, only whole coins.
Right.
And this idea was huge and laid the foundation for the entire field of quantum mechanics.
Wow, that's amazing. But how did this idea of quanta solve that light bulb problem?
Well, Planck's theory explained that the energy of light is directly related to its frequency.
Right.
So, like a hot object, it can only emit light in specific quantized amounts, which prevents that infinite energy output that classical physics predicted.
So in a way, Planck saved physics from a meltdown by introducing this idea of energy coming in tiny packets.
Exactly. And it didn't stop there. This concept of quantized energy even went on to explain other pretty mysterious phenomena like the photoelectric effect.
Ah, the photoelectric effect.
Yeah.
That's where shining light on a metal can cause it to emit electrons, right? I remember that from science class.
Right, but here's the thing. Classical physics couldn't explain why only certain frequencies of light would cause this effect. Like, the intensity of the light didn't seem to matter as much as the color, which was baffling.
Yeah. So how did quantum physics come to the rescue again?
Well, it was Einstein who built upon Planck's idea, and he proposed that light isn't just a wave, but also a stream of particles, each carrying a specific amount of energy. These particles were later named photons.
Wait, hold on. Light is both a wave and a particle. Yeah. Oh, that's just messing with my head.
I know, right? It's mind-boggling. And this concept of wave-particle duality is one of the core principles of quantum physics, and it challenges everything we thought we knew about how the world works. Like, it's like saying a cat can be both fluffy and a liquid at the same time.
Okay, I need a moment to process this.
Yeah.
So we've got light acting like both a wave and a particle. Where do we even go from here?
Okay, so let's zoom into the heart of matter itself, the atom. Our Veritasium video does a great job of explaining how our understanding of atomic structure evolved. It all started with Ernest Rutherford, a physicist who, in a moment of scientific genius, decided to shoot alpha particles at a thin sheet of gold foil.
Wait, he shot tiny particles at gold. Sounds like an expensive experiment.
Oh, it was a groundbreaking experiment. You see, Rutherford expected the alpha particles to just pass straight through the foil with maybe a little deflection. But to everyone's surprise, some of those particles bounced straight back.
That's like throwing a tennis ball at a spider web and having it ricochet back at you.
Exactly. And this unexpected result led Rutherford to propose a revolutionary new model of the atom. He concluded that most of the atom is empty space, with a tiny, dense nucleus at the center containing most of its mass.
So instead of being a solid sphere, the atom is more like a miniature solar system. with electrons orbiting a central nucleus.
You got it. But this new model created another puzzle. According to classical physics, those orbiting electrons should constantly be losing energy and spiraling inward, eventually crashing into the nucleus.
That doesn't sound good for the atom. What kept those electrons from spiraling into oblivion?
Enter Niels Bohr, another brilliant physicist who took a quantum leap, so to speak, in explaining atomic structure. He proposed that electrons can only exist in specific quantized orbits around the nucleus.
So instead of moving freely, those electrons are confined to specific energy levels, like cars on designated lanes of a highway.
That's a great analogy. Each orbit represents a different energy level, and electrons can jump between these orbits by absorbing or emitting energy in the form of light.
Uh-huh. So that's why we see those distinct spectral lines, like fingerprints, for each element. It's all about those quantum jumps between energy levels.
Exactly. And just when we thought we were getting a grasp on this quantum world, another physicist came along and blew everyone's minds.
Oh, I can't wait to hear this. Who was this revolutionary thinker?
Well, his name was Louis de Broglie, and he asked a question so bold it changed the course of physics. If light can act like both a wave and a particle, why not matter too?
Wait, he's suggesting that things like electrons, the building blocks of matter, could also act like waves. That's just crazy.
I know, right? But experiments soon proved him right. Electrons, when fired at a crystal, created interference patterns, just like waves do.
So the things that make up our solid world, they have this fuzzy, wave-like nature too. My head is spinning.
That's the beauty and the mystery of quantum physics. It challenges our everyday intuition and shows us that at the most fundamental level, the universe is far stranger and more wondrous than we ever imagined.
This is truly mind-blowing stuff.
Yeah.
We've gone from a simple light bulb to the wave-particle duality of light and matter. I'm on the edge of my seat, eager to see what other surprises this quantum world has in store.
And the strangeness just doesn't stop there. The real shocker is that this wave-particle duality, it isn't just some quirk of light and electrons. It points to a fundamental shift in how we even view reality itself.
Okay, you've got me intrigued.
Yeah.
What's so different about the quantum view of reality?
So, classical physics, the physics of our everyday world, is all about certainty. If you throw a ball, you can calculate its trajectory, predict where it'll land. It's deterministic.
Hey, cause and effect. Okay.
Pretty straightforward. But in the quantum realm, certainty goes out the window. Instead of predicting outcomes with absolute precision, we're dealing with probabilities. Mm-hmm. It's like saying, we know the ball is somewhere in this room, but we can't say exactly where until we look.
So instead of knowing for sure where something is or how it'll behave, we're talking about the chances of different possibilities.
Exactly. It's like rolling a die. You can't predict the exact outcome, but you can talk about the probability of each face coming up.
Right.
And here's the kicker. That fuzziness, that uncertainty, it isn't due to our lack of knowledge. It's built into the very fabric of the universe.
Oh, that's a pretty radical departure from the, clockwork universe of classical physics. Does this mean that at the subatomic level, things are just random?
Not exactly random, but definitely uncertain.
Yeah.
In a way that challenges our classical intuition. This is where Heisenberg's uncertainty principle comes in. It says that we can't know both the position and momentum of a particle with perfect accuracy at the same time. The more precisely we know one, the fuzzier the other becomes.
So it's like trying to pinpoint both the location and the speed of a tiny, super-fast particle at the same time.
Yeah.
The act of measuring one messes up the other.
Precisely. It's as if the act of observation itself influences the very reality we're trying to measure.
This is seriously messing with my perception of reality. Okay, so we've got this wave-particle duality, this inherent uncertainty. Is there anything else in this quantum bag of tricks that's going to completely blow my mind?
Oh, you have no idea. Get ready for entanglement. Arguably the weirdest phenomenon in quantum physics. Imagine two particles linked in a way that defies distance.
Okay.
And our common sense notion of separation.
Linked how? Like they're best buddies and they call each other every day, even across galaxies.
Not exactly, but the analogy is closer than you think.
Okay.
When these entangled particles are created, they become connected in a way that their fates are intertwined, no matter how far apart they are. Measure the state of one, and instantly you know the state of the other. It's as if they're communicating faster than the speed of light, which, according to Einstein, shouldn't even be possible.
Whoa. Faster than the speed of light? That sounds like something out of Star Trek. Did Einstein have anything to say about this apparent violation of his own theory?
Oh, he did, and he wasn't too happy about it. He famously called entanglement spooky action at a distance. because it seemed to imply that information could travel instantaneously across vast distances, which would contradict his theory of relativity.
So what's the verdict? Is entanglement just a theoretical quirk, or is it a real phenomenon?
The Novier documentary highlights how, over the years, numerous experiments have confirmed entanglement as a real, measurable phenomenon. It's one of the most bizarre and counterintuitive aspects of quantum physics, and yet it's absolutely real.
So entangled particles are like tiny telepathic twins, communicating instantly across space and time. This is officially the weirdest thing I've ever heard.
But here's the thing. This weirdness isn't confined to the quantum realm. It's starting to spill over into our technology, and it's poised to revolutionize the world as we know it.
I'm all ears. How is this, mind-bending quantum stuff going to change our lives?
Well, for starters, let's talk about atomic clocks. Remember how I mentioned that quantum physics introduced this idea of energy coming in discrete packets? Well, atomic clocks exploit that very principle to achieve incredible accuracy in timekeeping.
Okay, but how does that work? What do energy packets have to do with keeping time?
So atoms, like everything else in the quantum world, have specific energy levels. Atomic clocks measure the incredibly precise frequency of light emitted when electrons jump between these levels.
Yeah.
It's like having a super accurate metronome that ticks billions of times per second.
Wow, that's incredibly precise. But why do we need such accurate clocks? What's the big deal about a few nanoseconds here and there?
Those tiny fractions of a second add up. Atomic clocks are essential for GPS systems, which rely on incredibly precise timing to pinpoint your location on Earth. Without atomic clocks, our navigation systems would be hopelessly inaccurate.
So every time I use my GPS to find my way, I'm relying on the weirdness of quantum physics. That's pretty amazing.
It is. And let's not forget about lasers, another technology that wouldn't exist without quantum mechanics. Remember those electrons jumping between energy levels in atoms? Well, lasers exploit that same principle to create a beam of light that's incredibly focused and powerful.
Lasers are everywhere these days.
Yeah.
From barcode scanners to medical devices to fiber optic communication. It's hard to imagine a world without them.
Absolutely. And this is just the beginning. The field of quantum computing is emerging, promising to revolutionize everything from drug discovery to material science to artificial intelligence.
Quantum computers. Sounds futuristic. What makes them so different from the computers we use today?
They harness the strangeness of quantum mechanics, specifically the principles of superposition and entanglement, to perform calculations that are impossible for classical computers.
Right.
It's like having a computer that can explore multiple possibilities simultaneously,
Wow.
giving it a massive advantage in solving complex problems.
Okay, this is officially blowing my mind. We've gone from light bulbs to atomic clocks to quantum computers. This quantum journey has been incredible. What other amazing insights are out there waiting to be discovered?
Yeah, it really makes you wonder, doesn't it? What other seemingly impossible technologies might be just around the corner, all thanks to the strangeness of the quantum world. It's like we're on the cusp of a whole new technological era.
It's exciting and a bit unnerving at the same time. This whole deep dive has been a roller coaster ride. We started with that simple question about why a light bulb glows, and now we're talking about the fabric of reality and mind-blowing technologies that could reshape the world.
And it all goes back to the human element, our innate curiosity, our drive to understand the universe and our place in it. That's what led to the birth of quantum physics, and it's what continues to, propel us forward.
But here's a question that's been bugging me. We've talked about how observation seems to play a role in shaping quantum reality.
Yeah.
Does that mean our consciousness is somehow involved? Are we creating reality just by looking at it?
That's the million-dollar question. It's a question that philosophers and physicists have been grappling with for decades, and there's no easy answer. It delves into the very nature of consciousness and its relationship to the physical world.
So are we living in a Matrix-style simulation where our minds are creating reality?
Well, let's not jump to conclusions. While some interpretations of quantum physics do suggest a role for consciousness, it's important to remember that this is still a highly debated topic. There's no scientific consensus on whether or how consciousness might influence quantum phenomena.
Okay, so maybe we're not in the Matrix yet.
Yeah.
But seriously, what does all this quantum weirdness mean for us, for our understanding of ourselves and our place in the universe?
Well, I think it challenges us to, expand our thinking beyond the limits of classical physics and our everyday perceptions. Quantum physics reminds us that reality is far more mysterious and interconnected than we ever imagined.
It's like the universe is whispering to us, there's so much more to discover. So much more to learn.
Exactly. It invites us to embrace uncertainty, to be open to new possibilities, and to marvel at the wonders of a universe that constantly challenges our understanding.
This has been an incredible journey into the heart of quantum physics. We've explored mind-bending concepts like wave-particle duality, the uncertainty principle, and entanglement, and we've seen how these once obscure ideas are now shaping the technologies that are changing our world.
It's amazing to think that a theory that once seemed so abstract and esoteric is now having such a profound impact on our everyday lives. And who knows what other wonders await us as we continue to explore the quantum realm.
If this deep dive has sparked your curiosity, we encourage you to keep exploring. There's a whole universe of knowledge out there waiting to be discovered.
And who knows, maybe one day you'll be the one to make the next groundbreaking discovery that unlocks even deeper mysteries of the quantum world.
For more deep dives into the human element, be sure to visit us at 1337podcast.com. Thanks for joining us on this quantum adventure.
Strength and honor. I am Spartacus.
Thanks for watching. Tap into 1337podcast.com.